Today we will be starting with a very nice and important topic, and that is the topic of bounded sets. Bounded sets. So, what is the literal meaning of bounded? Bounded means something which is within particular boundaries. Okay. So, that is what we mean by bounded. Now, for example, if I look at the set A equals to 1, 2, 3, 4, 5. Then we know that it has got boundaries 1 and 5. What does it mean? It means if we take x belonging to A, x will be less than or equal to 5 and x will be greater than or equal to 1. So this is bounded from both the ends. Okay. If we look at the interval 0 or in fact we can say 1, 5. So if we take an element x in A, from above it is bounded by 5 and from below it is bounded by 1. But you can see that the boundaries are not attained. That means x cannot be equal to 1 or 5, but they are boundaries. Okay. So boundaries may or may not be attained by a set. So let us define bounds of a set. So M is called upper bound. M is called upper bound for a set A if x is less than or equal to M for all x belonging to A. Okay. And L is called lower bound for A if L is less than or equal to X for X belonging to A. So it may happen that a set has a lower bound. It may happen that a set has an upper bound. It may happen that a set has only one of the bounds. It may happen that a set has both the bounds. It may happen that a set has neither. Now let us look at some examples. Okay. So example number 1, if you look at the set of natural numbers, the set of natural numbers is 1, 2, 3, and so on. So what is the lower bound? 1. Okay. Because you can see that 1 is less than or equal to x for all x belonging to the set of natural numbers. But there is no upper bound. Because the set of natural numbers keeps on going on, there is no end to it. Okay. Let us look at this second set, which is set of negative integers. So the set of negative integers is -1, -2, -3, and so on. So what is the upper bound? Now they have an upper bound. Why? Because the maximum element in the set is -1. Okay. So x will be less than or equal to -1 for all x in this particular set A. Okay. But there is no lower bound. Why? Because the elements are decreasing and decreasing. So there is no lower bound. It will keep on decreasing. Okay. Third, set of integers. So what is the set of integers? Set of integers is 0 in the middle, 1, 2, -1, -2, and so on. So there is no upper bound because the elements are increasing and there is no lower bound. Okay. So there is no upper bound and there is no lower bound. And fourth, we need the upper as well as the lower bound. So you can take the interval 0, 1. So you can see that here 0 is less than equal to x less than equal to 1. So there is a lower bound and there is an upper bound. So we have seen all the 4 kind of examples. Okay. So where we have the lower bound as well as the upper bound. Okay. So a set is said to be bounded above. Okay. If it has an upper bound. Okay. And the set is said to be bounded below if it has a lower bound. Okay. And a set is said to be bounded if it has both. Okay. Now let us see some examples. So the first example is A is the open interval 0, 1. So you can see that the elements are between 0 and 1, but 0 and 1 are never attained. 0 less than x less than 1. Example number 2 is the closed set 0, 1, where all the elements from 0 to 1 are included. So the bounds 0 and 1 are attained. Number 3, open sets, closed and open, half open, half closed, at 0, open at 1. So there is a lower bound 0, but the upper bound is there, but it is not attained. And similarly, fourth, open at 0, that is not attained, and closed at 1, which is attained. Okay. So all these four examples, if somebody asks you, all these four examples are bounded sets because we have upper bound and lower bound. So what is the criteria of a bounded set? The criteria of bounded set is that we must have a element and below, and we must have an element above. And the elements of my set has to be between these elements. Now, these endpoints may or may not be in the set. So this is the definition of bounded set. Okay. Now, after you understand the definition of a bounded set, the next important thing that should come up to us, what is closed set? Okay. So what is a closed set? Okay. So in mathematics, in very simple language, closed set means bounds are attained. Okay. The bounds should be there in the set. So bounds are attained by the set. Therefore, this particular set was a closed set. Okay. And all the other sets, they were not closed. Why? Because either of the boundaries were not attained by the set. So that is the difference between a closed set and a bounded set. Okay. So a bounded set may or may not attain its boundary. A closed set is bounded, but it has to attain the boundary. Okay. So let us come to the real life, or in fact, real analysis definitions of open sets and closed sets. So we have open sets. So what are open set? A set A is said to be open if for all x belonging to A, there exists, okay, if for all belonging to A, there exists an open interval, there exists an open interval containing A, containing x, contained in A. What does it mean? It means that if A is my set, for example, if I look at this set, 0 and 1, okay, so open at 0 and open at 1. So let us look at this set 0, 1. So I want to know whether this is an open set or not. What does it mean? For every x in A, for example, I take an x here. There should be an open interval containing x. इस x के around एक open interval होना चाहिए जो इस पूरे set के अंदर हो. So you can see that whatever x I choose, there will be an open interval which will be containing this set. And that is why this is called an open set. Okay. So if you look at, this particular one, now this 0, now somebody will say, what about 0 and 1? Can we take x to be 0 and 1? Of course not, because 0 and 1 are not included in this set. So if I take any element between 0 and 1, I will be able to construct an open interval around that element, which is contained in this interval 0, 1, and therefore it is an open set. Now, let us look at another example. So let us look at this particular interval. So where 0 is included, but 1 is not included. Okay. So now this is my set. Is this open? Is this open? So what is the definition of open set? Definition of open set is that for every element in the set, there has to be an open interval around that element, which is inside the set. So look at 0. Now 0 is a part of this set now. Now, no matter how small open interval I take, there will be some portion which is not inside 0, 1. And therefore, this is not open. This is the basic definition of an open set. So what is an open set? An open set is the one wherein for every element belonging to this set, I'm able to construct a small open interval containing that element. And that open interval has to be inside the set. That is the definition of open sets. So you can see that these are not open sets. Okay. Now, what are closed sets as far as real analysis definition is concerned? So what are closed sets? A set A is called closed if its complement is open. Now, this is very interesting. Okay. Now, let us see. So let us look at closed interval 0, 1. Okay. Is it a closed set? We don't know. Is it an open set? No, it is not an open set. How? Because you can see that this is 0, this is 1. So if I take any neighborhood of 0, any neighborhood or any closed interval containing 0, there will be some portion which is outside the set. Similarly, with 1, there will be some portion which is outside the set. So this is not open. Okay. Is it closed? Is this set closed? Let us see. So what is the complement? Complement means real numbers minus this set. So what is the complement? What is the complement of 0, 1? It is, we go from minus infinity to 0 and then union 1 to infinity, because I will have to remove the set 0. Now you can see that, you can very well see that this is open and this is open, because whatever element I choose inside these sets, there will be an open interval around that element inside the set. So that is why this is open, union of open sets is open. Okay. So yes, the complement is open, therefore 0, 1 is closed. Okay. Let us look at another example. Let us look at closed at 0, open at 1. Is it open? Is this set open? No. Why? Because you look at 0, 0 is in this set. So if you take a neighborhood, of 0, there will be some portion which is not in the set. Therefore, this set is not open. Next question is it closed? Is it closed? So look at the complement. So what is the complement of the set? I have to remove this interval 0, 1. So I will come from minus infinity to 0, and 0 will not be included because 0 is included in the set. Then I will be starting from 1. Now, why 1 is included? Because here 1 is not included. So in the complement, it will be included. Okay. Now this set is open, but this is not open. And why this set is not open? Because of this closed bracket 1. Because if I look at 1, there will be an interval, there will be a portion of the interval which is not in the set. So the complement of this particular set is not a union of open sets. Therefore, it is, the complement is not open and hence it is not closed. So you can see example that it is not necessary that if a set is not open, it is closed. So we can have a set which is neither open nor closed. Okay. So what are the categories of sets we have? We can have open sets, we can have closed sets, and we can have neither open nor closed. So example 0, 1, close set, example, close interval 0, 1, example. Okay. Now, right now I am taking all intervals. Let me take example of a finite set. Let A be the set 1, 2, 3, 4, 5. Is it open? So what is the definition of an open set? For every element in A, there has to be an interval around that element which is inside it. Okay. So 1 belongs to A. Now, if I put 1 on the real number line, there should be an interval, no matter how small it is. So this interval contains element less than 1 and more than 1, but less than 2. Okay. And this particular interval is not inside A. Because A only contains 5 elements, 1, 2, 3, 4, 5. So whatever element I choose, I will never be able to find an interval containing that element which is contained in the set. So therefore, finite set, a finite set is never open. Okay. Is it closed? Let us see. So let us look at A complement. So I have to remove this element. So I will go from minus infinity to 1, then 1 to 2, then 2 to 3, then 3 to 4, then 4 to 5, and then 5 to infinity. So you can see that all these intervals are open intervals, and therefore they are open sets, and union of open sets is open. So A complement is open, and therefore A is closed, and therefore every finite set is closed. So every finite set is closed. So this is, if you go deeper into the concept, this is the definition of open sets and closed sets. But where did we start? We started with bounded sets. The bounded sets may or may not include bounds. Okay. What is a closed set? A closed set is the one which is bounded plus include bounds. Okay. Now, what do you mean by another thing? What do you mean by a compact set? Okay. What is the meaning of compact in English language? Compact means which can be enclosed into something, which can be enclosed into a bigger set. उसको compact बोलते हैं. ठीक है. So, what is a compact set? A closed and bounded set. A closed and bounded set is said to be compact. Now, for example, if I make a diagram, okay, so let me make this diagram. We have a triangle, okay, and we have this shaded region. This triangle is shaded and the boundaries are also solid. So this figure consists of triangles inside plus boundary. So this is closed and bounded. It is a compact set. Okay. If you look at this is only interior. You can see only the interior of the triangle is there. So therefore, this set is bounded. Why? Because boundary is there. I cannot go beyond these sides A, B, C, A, B, B, C, and AC. But boundaries are not included. Boundaries are not included. So this is bounded, but boundaries are not included. So therefore, it is not closed and hence not compact. Okay, so we studied three types of sets today: bounded sets, closed sets, compact sets. So bounded sets, which is bounded from below and bounded from above, boundaries may not be included. Closed sets, the boundaries have to be included. And in fact, we had discussed the real life or real analysis definitions of closed and bounded, or closed and open sets. So open sets, for every element in the set, there has to be a neighborhood around that element which is contained inside the bigger set. Closed set, a set is said to be closed if its complement is open. Okay. Compact set, a closed and bounded set is compact set. Compact set means a set which can be enclosed in a bigger closed and bounded set. So that is called compact set. All right. So for example, let us take this particular set. A, 1, 2, 3, 4, 5. Is it compact? ये closed है because it is a finite set, we discussed. ये bounded है. ये bounded है because 1 and 5 are the boundaries included. So closed plus bounded is compact. And in fact, you can see that compact set means I can actually contain this particular set in a closed interval, and that closed interval is 1, 5. And therefore, I can pack it. And therefore, this set is called a compact set.